Hi guys, let's look at the next question. Next question is question number 10, part 9. It says, in fact, this part has three parts to it: left hand side, middle side, and the right hand side. So let's look at this. Cot square A minus cot square B, and we need to prove it to something. So let's look at this. Let's start with the left hand side. This is cot square A minus cot square B. The relation between cot and cosec is 1 plus cot square is equal to cosec square. So let me just write this is cot square A. So let me write cot square A as cosec square A minus 1, and this becomes minus cosec square B minus 1. Let's open the bracket. This would be cosec square A minus 1 minus cosec square B plus 1. So plus 1 minus 1 gets cancelled. This is cosec square A minus cosec square B. So this is my third term. So we started with left hand side. We can also call it the first term. This is equal to right hand side. We can also call it the third term. Let's move on with this only. So let's look at this term. So now we are working with the right hand side. So right hand side says cosec square A, and I need to convert this into a denominator of sine square A sine square B. As soon as I realize that this is 1 upon sine square and this is also 1 upon sine square, I think I've already got my denominator. So let's see how would it look. Before that, I need to write a reason. Reason would be since cot square theta is equal to cosec square theta minus 1. That was the only reason here. After that, we've done nothing. Here, this would be 1 upon sine square A minus 1 upon sine square B. Let's take LCM. The LCM would be sine square A dot sine square B. I think I've already got my denominator. Let's see how do I get my numerator. So if when I've taken the LCM, this would become sine square B minus sine square A. One reason which is since cosec theta is equal to 1 upon sine theta. Done. Next would be, let's move from here and see how does it give us the answer. So here this would be sine square B. They want cos square, so the relation between sine square and cos square is sine square theta plus cos square theta is equal to 1. Let me replace this with 1 minus cos square B minus, let me replace sine square A with 1 minus cos square A. So instead of sine square B, I have written 1 minus cos square B, and instead of sine square A, I have written 1 minus cos square A. Denominator remains the same, sine square A dot sine square B. Reason would be since sine square theta is equal to 1 minus cos square theta. Let's open the bracket. This will be 1 minus cos square B minus 1 plus cos square A upon sine square A dot sine square B. Minus 1 plus 1 gets cancelled, and this is cos square A minus cos square B upon sine square A dot sine square B, which is nothing but the middle term or second term. So since LHS is equal to RHS is equal to middle term, hence proved. Done. Very easy, but had 3 terms to it. Good. Let's look at the last 2 questions from this exercise that we do, which is question number 10, part 10. It says cot A minus 1 upon 2 minus x square A is equal to cot A upon 1 plus tan A. Let's try with the right hand side and let's try and rationalize it. So I know 1 plus tan A into 1 minus tan A will give me 1 minus tan square A, which will have some which I can convert somehow into sec square. Let's look at this. So right hand side I will do rationalization. So this would be cot A upon 1 plus tan A. Let's multiply it with 1 minus tan A upon 1 minus tan A. This gives me cot A multiplied with 1 minus tan A upon 1 minus tan square A. Good. This is cot A into 1 is cot A minus cot A into into tan A is nothing but 1, and this instead of, I've got my numerator now. Let's see, in the denominator they don't want tan, they want sec. The relation between tan and sec is tan square A is equal to sec square A minus 1. So this is 1 minus sec square A minus 1. Let's write the reason. Since cot A into tan A is equal to 1, because they are reciprocal of each other. Perfect. And the second reason was since tan square A is equal to sec square A minus 1. So this becomes cot A minus 1 upon 1 minus sec square A plus 1, which means cot A minus 1 upon 2 minus sec square A, which is equal to left hand side. So since LHS is equal to RHS, hence proved. Now let's look at the last question from this exercise, question number 14. Question 14 has cosec minus cos multiplied with sec minus cos multiplied with sec square is equal to tan A. This question appeared in your 2011 boards. Let's try and convert everything into sine and cos, because eventually right hand side I have only tan. So let's convert. So cosec would be 1 upon sine A minus sine A. The second term would be 1 upon cos A minus cos A, and sec square would be 1 upon cos square A. The reasons we've used here are since cosec A is equal to 1 upon sine A and sec A is equal to 1 upon cos A. So two reasons, let's add them, in this case subtract. So this will be 1 minus sine square A upon sine A, that's my first bracket. This would become 1 minus cos square A upon cos A, that's the second bracket, and this is 1 upon cos square A. 1 minus sine square A is nothing but cos square A upon sine A, multiplied with 1 minus cos square is nothing but sine square A upon cos A into 1 upon cos square A. The reason would be since sine square theta plus cos square theta is equal to 1. So let's see if something gets cancelled. Cos square A and cos square A gets cancelled. Sine A and the second power get cancelled. So this is sine A upon cos A, which is tan A. The reason being since sine theta upon cos theta is equal to tan theta, and this is nothing but the right hand side, so hence proved. Done. That finishes this exercise for us. Let's look at some homework questions. Homework question would be question number 15. That's about it. Thank you so much. Take care, be safe. I'll see you with the video for exercise 21D now, where we learn how to read, not learn, we've already done that last year in grade 9, so we'll revise and see how to read the trigonometrical tables. Bye bye.